Okay, so I'm going to try and talk through a model solution version of Lab 3 and give you some advice on how to go about this lab and also how to verify that you got this lab configured and working properly. So the first thing we're going to do is we're going to look at our IP address. So I'm going to go to the Edit menu in VMware and then choose Virtual Network Editor. And in the Virtual Network Editor, we're going to find our NAT network. And we'll notice that it has a subnet address of 192.168.40.0. Yours will probably be similar, but it may have a different third octet right here. It's usually randomly assigned by VMware when you install it. Mine is .40, yours might be different. So we need to make note of that IP address. The other thing in here we can see is this checkmark, the Use Local DHCP Service. Once you get done with task 4 and have your DHCP server running, you'll want to go in here and uncheck this box. You have to click this Change Settings button to give it admin access, but then you can uncheck this box to turn off VMware's DHCP service so you can use your own. So remember, we have 192.168.40. So up here in Ubuntu, we want to set a static IP address in that same range. So in my settings, if I go in here and look at IPv4, you can notice that I've set an IP address 192.168.40.41. And the .41 is what the assignment says that we're going to use for our Ubuntu server. We also need to set the gateway. In VMware, it uses a default gateway of .2 inside of your network. The reason it does this is .1 is usually used by your home routers and some other services. And so to avoid any conflicts, VMware has set it to .2. We also have the net mask of 255.255.255.0. That's pretty standard. We talk about that in the lecture. And then you notice that right now I've actually set it to refer to itself as a DNS server. Originally in the lab, you'll probably set this to .2 so that you still have working internet. But once you get your DNS server working, you can set it to .41 so that it actually refers to itself for its DNS. So we'll go ahead and apply this. Once you apply it, you can turn it off and turn it back on to make sure it's applied. This is the only VM in this lab that you need to set a static IP address on. I've seen some students try and set static IPs on the Ubuntu and the Windows. You don't need to do that. For testing of your DNS server, you can set a static DNS entry temporarily, but the idea is by the time you get done with Lab 4, these two, your Ubuntu client and your Windows client, should both be getting its IP address from the DHCP server on your Ubuntu server. Okay, so once we have that set, we can confirm our IP address is correct by doing IP-addr show. That will show us our IP address. And we'll notice right here that we see the 40.41 IP address. We also need to keep in mind this ENS33. This is the name of the interface that this is connected on. And so in the DHCP setup, you'll need to go in and set a file that defines which interfaces to listen on. This is the interface we want to listen on. But for the DNS server, we actually tell it the IP address that we want to listen on. And so we'll need this IP address in our DNS server configuration. So once we have our DNS server up and running, we'll also need to make sure that we allow it through the firewall. I'll leave that up to you. You can look up what ports you need and how to allow that through the firewall. But if it's working, we can use the dig command followed by an @ symbol and the IP address of our system. And so what this does is this tells dig to ignore any DNS settings we have on our system and query this particular server. And we're going to query for ns cis527 rosfeld.cs.ksu.edu. And when we do that, we get this response. Here, I'll just to help, let me put this command back up here again. So I'm doing dig at the IP address of my server, and you can do this either on the server or on the clients. And then I'm giving it the name of a server that I want to look up in our DNS configuration. And so if I run this command, in this answer section, I should get back that this name goes to this IP address, which is correct. So that's how we look up an entry on our forward zone. If we want to look up an entry in our reverse zone, instead of doing the name, we do -x, and then we would put in an IP address. I'm going to put in the IP address 42, which when we do this, it will show our answer section is we're looking up 42.40.168.192.inadder.arpa, which is the reverse lookup IP address. And then we are getting our Windows server back. So to really check to see if your DNS server is working, those are the two commands you need. You just need to be able to use dig at your server's IP address and then -x for reverse lookup, or for a forward lookup, you just put in a domain name. You can also test your forwarding. If you want to make sure your forwarding is working, I can dig that server and just look for www.yahoo.com, for example, and I can get responses from that. I can also look up the reverse. If I want to look up a reverse, I can do a reverse for 208.67.222.222, which is one of the OpenDNS resolvers. So this is pretty much confirmed that our DNS server is working on the server. If you want to check it from one of your clients, you can switch over to your clients, and here on the client, I can run those exact same commands. So if I do dig at my server IP address, and this is without setting any static DNS entries. This is just telling dig to query this IP. And then if I do my address here, then I can run it. And once again, we're getting that answer. And so this is how you can test your DNS configuration before you have DHCP working. You don't have to change anything on your client. You just use the @ symbol in your dig command to tell it to query that particular DNS server for this entry. So that's the DNS parts. If that doesn't work, there's a really good guide on DNS troubleshooting that talks you through a lot of different things you might run into. Be especially careful of your periods and your spacing in your DNS configuration files. All of that is really important. There's also a really good discussion on Piazza right now about the number of octets in your reverse zone file. In the .local file, you can have 3 octets, and then you only need 1 octet in your zone file. If that doesn't make sense, post on Piazza, let us know. We can try and clarify that. Okay, so the second part is your DHCP server. And the DHCP server configuration is pretty simple. However, I'm going to call out one thing real quick. If I go to /etc/default, you'll notice there's a file in here that might exist that's, helps if I go to the server. If I go to the server and then look in here, you'll see there is a file called ISC DHCP server. And so in this file, it has some entries, and depending on what guide you read, sometimes you will need to define an interface right here that your DHCP server could listen on. Mine, I didn't need to define that. It just worked, but in a lot of cases, you might need to define that. So this is where you would put that ENS33 that we saw earlier. So once you get your DHCP server running, you can start it. I'm just going to restart mine. So I restart that. And now your server should be running. If you want to check, a good way to check is you can do sudo cat /var/log syslog, and we'll look at the very end of our syslog, these last few entries, and we can see here that our DHCPD server started up, it read its config file, and then it will say things like listening and sending. And as long as you see that it's listening on ENS33, that means it's working. If you get an error here that says it's not configured to listen on any interfaces, that's where you might need to change that defaults file to listen on ENS33 to work. So that's how you can tell your DHCP server started correctly. There's a couple other commands that you can use using the ss command to look at listening ports. So ss-l will show you all the listening ports on your system. However, it's not very useful at all. So instead, we can try 2 different versions. I'm going to do ss-l, then I'm going to do t, which will listen for TCP ports only, and then in, which will show us the port numbers. So if I do ss-ltn, I will see really quickly that I have a DNS server listening right here on port 53. That's what we're looking for DNS. DHCP, however, is not TCP, it is UDP. And so if I look for UDP, I'll see a DHCP server listening here on every IP address on port 67. And so there is the entry for your DHCP server. And so if you're not sure if your servers are running correctly, you can use ss-ltn or ss-utlun and look for entries that end in 53 for your DNS server or 67 for your DHCP server. You'll also notice that there is 161 for your SNMP server if you have that running. So this is kind of a really useful thing. You can also see your SSH server running on 22222, and we'll see our HTTP server Apache running on port 80. So a couple of quick commands, but the really easy way to test your DHCP server is actually on Windows. And so on Windows, I have no static IP address set. If I do ipconfig/release, that will release all of our IP configurations. And then I can do ipconfig/renew to force it to renew that IP address. And so it will think for just a minute, and then it will come back, and it should give us an IP address that has something within our range. It has .2 as the gateway, but the big giveaway is you can find this connection-specific DNS suffix, and it will contain your EID. That's the dead giveaway that you are getting a DHCP address from your DHCP server, and that's why it's actually really easy to test this on Windows. Now, if I do ipconfig all, then it will show all the information, and you can see that it also is getting the DNS server for your network. And so it actually gets the right DNS server. It will also show you what your DHCP server is. So if you want to know where that IP address came from, you can find it here as well. And then of course, we can use NSLOOKUP to look up different names on our network. So if I do NSLOOKUP, I can look that up. And if I do the reverse, I can get the reverse as well. So everything is looking really good here. The other thing you can do, obviously, for testing is on your Ubuntu client, you can do sudo dhclient-r, which will run the DHCP client and refresh. If I do -r, sudo dhclient-v, you'll actually see it sending the DHCP discover. So it sends it to discover, then we get an offer of this IP address from our server IP, and you can see that it works. So those are a quick overview of what lab3 should look like when it's working correctly. The big things to do are get your DNS server up and running and then test it here on your server using those dig commands with the @ symbol on them. So if we go back through my history, we find some of these dig commands having the @ symbol where we can query a particular DNS server and look up a particular address. Once you get that working, you can then test it from your client using that same syntax, or you can just go ahead, get your DHCP server up and running, check the system log to make sure it's running, and then go to your Windows client, reboot it, and make sure that it's getting an IP address from your system, and then you should be good to go. If it's not working, check your config files, check your firewall, make sure that it's listening on the right ports, or feel free to reach out on Piazza and let us know. So I hope this video is helpful. If you have suggestions or questions or anything else I can go over, please let me know. Good luck.